What's up guys, and welcome back to another tutorial video right here in the Calculus Stories channel. Now for this tutorial, let's go ahead and jump right in and look at the problem that we're going to be dealing with. So suppose we are conducting a study on the growth of plants in the RGB area during the year 2013. In 2015, there were 59 plants, and in 2021, there were 118 plants. Now, the number of plants can be modeled by the function p given by p of t is equal to a times b to the t power, where p of t is the number of plants during year t, and t is the number of years since 2013. Now, for our first part, we want to go ahead and find the values for a and b as decimal approximations for our function p of t. Now, before we actually jump into this exercise and solve for a and b, let's go ahead and define what a and b are. Now, a represents the initial number of plants in 2013 designated by t is equal to 0. B of t is the exponential growth factor, and just like the problem mentioned, t is equal to the number of years since 2013. And so we'll go ahead and start this exercise by going ahead and solving for b. Now, before we can go ahead and solve for b, let's go ahead and define our p of t equation during the year 2015, designated by t is equal to 2. So plugging in 2 for the value of t, we'll go ahead and end up with the equation p of 2 is equal to a times b squared. Now, we know that during the year 2015, designated by t is equal to 2, there were 59 plants. And so we can go ahead and replace p of 2 with 59. And so our equation becomes 59 is equal to a times b to the second power. Now, with this equation alone, we don't have enough information to go ahead and solve for either a or b. And so let's go ahead and repeat the same process, but with the year 2021 designated by t is equal to 8. And so by repeating this process, we'll go ahead and come up with p of 8 is equal to a times b to the 8th power. Now, we know that during the year 2021, there were 118 plants. And so by replacing p of 8 with 118, we'll go ahead and get the equation 118 is equal to a times b to the 8th power. Now, with these two equations, you have to realize that a is never going to change because it's the initial value of plants during the year 2013. And so by expressing both equations in terms of a, we'll be able to go ahead and set them equal to each other and solve for b. By doing this, our equations are going to become 59, which is equal to a times b squared. And expressing this equation in terms of a, we'll go ahead and end up with equation a is equal to 59 divided by b squared. And applying these same steps to equation 2, which is 118 is equal to a times b to the 8th. By expressing this equation in terms of a, we'll go ahead and end up with a is equal to 118 divided by b to the 8th power. And so now that both equations are expressed in terms of a, we can go ahead and set these equations equal to each other. And by setting these equations equal to each other, we'll go ahead and end up with the following expression. 59 divided by b squared is equal to 118 divided by b to the 8th. And so notice that in this expression, all we have is one unknown variable to solve for. And so it becomes a much more simpler equation to solve for in terms of b. And so by multiplying both sides of this equation by b to the 8th, we'll end up with the equation b to the 8th times 59 over b squared is equal to 118 divided by b to the 8th times b to the 8th. And so we'll just go ahead and end up with 59 times b to the 8th, all divided by b squared. And on the right hand side, by multiplying 118 over b to the 8th by b to the 8th, b to the 8th will just go ahead and cancel out, and we'll just go ahead and end up with 118. And so let's go ahead and continue simplifying the left-hand side by using exponential properties. And so we can go ahead and rewrite the left-hand side by saying 59 times b to the 8th minus 2 is equal to 118. And so by using this exponential property, all we'll get is 59 times b to the 8 minus 2, which is 6, is equal to 118. And so to go ahead and get rid of the 59, let's just go ahead and divide both sides by 59, and we'll end up with the equation b to the 6th power is equal to 118 divided by 59. Now, the problem was explicitly asking for b, not b to the 6th. And so to go ahead and get rid of that b to the 6th, we'll just go ahead and take the 6th root of both sides, and by doing that, we'll go ahead and end up with the expression b is equal to the 6th root of 118 divided by 59. And using a calculator to evaluate this expression, we'll get that b is approximately 1.12. Now, when it comes to solving for a, it's not as difficult as it was solving for b, because some of the equations that we came up with for b are some of the equations that we'll go ahead and use to solve for a. And so what I mean by that can be expressed in this paragraph. When we were solving for b, we came up with the equations a is equal to 59 divided by b squared, and a is equal to 118 divided by b to the 8th. Now, by using any of these equations, we can go ahead and get the value of a, since we already know what the value of b is. So let's go ahead and choose the first equation to go ahead and solve for a. And so we'll have a is equal to 59 divided by b squared, which is equal to 59 divided by 1.12 squared, which is the value that we found for b in our last part. And by using a calculator to evaluate this expression, we'll get that a is approximately 46.8. Our answer for a. Alright, so for the second part for this exercise, we want to go ahead and use the given data that they gave us to go ahead and find the average rate of change of the number of plants from t is equal to 2 to t is equal to 8. And so with this table that we have right here, let's go ahead and input what we know. So we want to find the average rate of change, and we'll go ahead and get to what that means in just a bit. From t is equal to 2 to t is equal to 8. So under the t column, we'll go ahead and start with a value of 2 for t, which represents the year 2015. And we know that in the year 2015, there were 59 plants. Now, in our second entry, we'll go ahead and input a value of 8 under the t column, and we know that this represents the year 2021, where we had 118 plants. Now, when it comes to the average rate of change, the average rate of change is just another fancy word for slope. And if you go ahead and think back to your algebra days, you know that slope is equal to y2 minus y1 divided by x2 minus x1. Now in this case, y2 represents the number of plants in 2021, which is 118, minus y1, which is 59, all divided by x2, which in our case is 8, minus x1, which is 2. And so simplifying this, we'll get 118 minus 59, which is 59, and 8 minus 2 is 6. And using a calculator to approximate this value, we'll get that the average rate of change is equal to 9.83. And so what this number means is that there is an average rate of growth of 9.83 more plants per year. Alright, so for this last part, we want to go ahead and use the average rate of change, which we found in section 2, to estimate the number of plants when t is equal to 10, or in other words, the year 2023. Now, we know from section 2 that the average rate of change, or in other words, the slope, was equal to approximately 9.83. Now, if you want to get an estimate for the number of plants when t is equal to 10, or in other words, 2023, we're going to have to use the equation y minus y1 is equal to m parentheses t minus t1. Now, we're going to have to first formulate this equation before we can actually calculate the number of plants when t is equal to 10. And so to go ahead and formulate this equation, let's go ahead and use a point that we already do know. So we know that when t is equal to 2, representing the year 2015, we have 59 plants. And so by using these data values, our equation becomes y minus y1, which is 59, is equal to m, the slope, which was calculated to be 9.83, times t minus t1, which in our case is 2. Now, by setting up this equation, let's go ahead and write this expression in terms of y. And so we'll have y minus 59. And on the right-hand side, by distributing, we'll get 9.83t minus 19.66. And so let's go ahead and cross over the 59 from the left-hand side by means of addition, and our equation is going to become y is equal to 9.83t minus 19.66 plus 59. And so the final step, to go ahead and simplify our equation, we're going to get y is equal to 9.83t plus 39.34. And so now that we've formulated our equation, we can go ahead and plug in 10 for the value of t, so we can get an approximation as to the number of plants that are going to be in existence when t is equal to 10, or in other words, 2023. And so by plugging 10 for t, we'll get y is equal to 9.83 times t, which is 10, plus 39.34. And using a calculator to evaluate this expression, we'll get that the value for y is 137.64. And so by using this linear approximation, at t is equal to 10, which is a representation of the year 2023, the number of plants is approximately 138, our final answer. Alright, so if you guys have any questions, just go ahead and drop those questions down in the comments, and I'll go ahead and see you back here for my next video.